Hello everyone, welcome to today's session. That's CBSE Class 11 Maths. In that, we look at trigonometric functions today. So in trigonometric functions, let's look at the trigonometric identities. Okay, so in this session, the learning objective here is at the end of this session, you will be able to know what the trigonometric identities are and also learn and apply the fundamental identities where required, and also we will be able to prove and solve some of the problems using the identities, and also we will look at the board style solving the problems step by step. Okay, so that's the objective. So let's move on to uh, yeah, before we get into the trigonometric identities, let's understand the trigonometric ratios, right? So in your class 10, you would have learned about the trigonometric ratios. So I'll give a quick brief on the trigonometric ratios, right? So trigonometry, we basically learn about a right angle triangle, right? So let's look at this. So this is a right angle triangle. And we learned in our previous classes that let's say this is A, B, C. This is a right angle triangle with right angle at C, right? Then this is the hypotenuse. And if this is the angle in the triangle, then this is opposite side. I'm just mentioning as OPP. And this is adjacent side. Okay. So we learned all the 6 trigonometric ratios. So we say sine theta or sine C or maybe sine X, whatever the angle is, right? So here sine theta is opposite side by hypotenuse, right? Hope you guys are following, right? And then cos theta is adjacent side by hypotenuse. And what is tan theta? Tan theta is opposite by adjacent. Also, we can get this using sine theta by cos theta. Similarly, we have cosecant theta, which is the reciprocal of sine theta. So 1 by sine theta, that is hypotenuse by opposite side. And similarly, we have secant theta. So secant theta is 1 by cos theta, which is the reciprocal of cos theta. So this we can write as hypotenuse by adjacent side. And then we also have cot theta, which is the reciprocal of tan theta. So 1 by tan theta, that we can write as adjacent by opposite. And also in our previous classes, we learned about Pythagoras theorem, right? So what is Pythagoras theorem? The hypotenuse square is equal to the sum of the squares of the other two sides in a right angle triangle. So hypotenuse square equal to opposite side square plus adjacent side square. Or we can write this as AC square equal to AB square plus BC square. So these are the basics of trigonometry that we have learned in our previous classes, right? So there are 6 trigonometric ratios. So what we have learned so far in our earlier classes, that is the trigonometric ratios in a right angle triangle. Now, let's learn that in radians. Okay, let's learn the trigonometric ratios in radians. So what is radian? We learned in our previous session that the radian is in an unit circle, right? In an unit circle, the angle subtended at the origin, right? At the origin, which is x, if the length of the arc, that is AP here, right? If AP is 1 unit, then that angle is nothing but a radian, right? And we also learned out how to convert a degree into radian and also radians into degrees, right? So let's look at this triangle, this diagram here. So in this diagram, this is a quadratic plane, right? So this is, I can say this is at 0 degrees. And this is 90 degrees. 0 to 90 degrees is the first quadrant, right? And then 90 to this is 180 degrees. 90 to 180 is the second quadrant. And then 180, this we can say 270 degrees, right? 90, 90. I'm just adding. 90 plus 90 is 180. 180 plus 90 is 270. So this is between 180 and 270. This is the third quadrant. And between 270 and 0, or we can also say this as 270 plus 90, which is 360 degrees. So fourth quadrant, right? This is the fourth quadrant. So 0 degrees or 360 degree, both are same, right? Now, if I want to write this into a radian angle, right? So 0 is 0. If I want to convert 90 degrees into radians, what I can say, 90 degrees into radians, right? So I can say 90 into, what is the conversion factor? Pi by 180, right, guys? So 91, 90. This is pi by 90 is pi by, that is in terms of radian. And this is pi by 2 plus pi by 2, right? Or 180 into pi by 180, which is pi. You're following, right? 180 degrees is nothing but 180 into pi by 180. That is pi radian. And then 270 will become 270 into pi by 180, or you can just add pi by 2 to pi. It will be 3 pi by 2. And then this is 3 pi by 2 plus pi by 2, which is 4 pi by 2. That we can also write as 2 pi. Following, right? So quadratic plane, we have indicated what are the different angles in each quadrant, right? So 0, pi by 2, pi, pi by 2, and 2 pi. Now, look at this, right? Look at this triangle here, triangle OPM, right? Delta OPM. It's a right angle triangle, right? So, in this, what is sin x? This is the angle subtended at the origin, right? So, what is sin x? What is the opposite side? So sin x is opposite by hypotenuse, guys. What is opposite? Opposite is PM. PM. So what is hypotenuse? OP. So what is PM here? Here P is a point on this unit circle, which is A comma B. So if this is A comma B, that means OM is A and PM is B. Right, guys? This is the X quadrant and this is the Y coordinate. Now, what is PM? That is by. What is OP? It's a unit circle, so the radius, in this case, it's a hypotenuse, that is 1. So here we can say sin x is P. And similarly, what is cos x? Cos x is what? Adjacent by hypotenuse. So what is adjacent side, guys? Here the adjacent is OM, which is A by OP. So that is A by 1. So we can say cos x equal to A. So that means we have any point on the circle, right? If I have any point A comma B on the circle, then A is nothing but cos x and B is nothing but sin x. Or I can write P of A comma B as, what is A? A is cos x comma sin x. So if we know the angle, we can get the point on the circle using cos x and sin x. 30 degrees, right? For example, x is 30 degrees, then the point A comma B will become cos 30 and sin 30. Cos 30 value we know. Cos 30 is what? Root 3 by 2 and sin 30 is 1 by 2. So that will be the point on that circle. You following, guys? So the trigonometric ratios in terms of radians, right? So in terms of radians, how we get in terms of radians is, instead of substituting the values 30, we will say pi by 3, right? So 30 degrees is what? Pi by 3. Let's say 30 degrees. So what is 30 degrees equivalent in radians? 30 degrees equal to 30 into pi by 180. So 31, 36. It's pi by 6. So sine 30 also I can write as sine pi by 6. Okay, in terms of radians. Now let's look at sine values, cos values, various angles. Okay, so as I said before, this is 0, 90, 180, This is 270 and this is 0 or this, right? If I write this in radians, then this is pi by 2, this is pi, and this is 3 pi by 2, and this is pi, right? 60 degrees is nothing but. Now, what is sine 0? Sine 0 is nothing but this value, right? So when x is 0, nothing but OA, right? So what is sine x basically? Let's do this, right? What is sine x? So sine x equal to b, right? So sine 0 degrees means this b will be 0, right? This point here is 1 comma 0, so this is a and this is b, right? So what is sine x? Sine x is b, so sine 0 is 0, right? What happens? Sine pi by 2, right? Sine pi by 2. What is sine pi by 2? That is 90 degrees. What is the point here? 0 comma 1. A and B. That means sine pi by 2 is 1, right? The y coordinate. Similarly, what is sine pi? What is sine pi? And pi is, if this angle up to here, this is 90. And if comes up here, this is 180. Guys, so 180, sine 180, and this is a comma b. When it is 180 degrees, even here, this point, right? So what is the point here? Minus 1 comma 0. The y quadrant is 0. So sine pi value becomes 0, right? You're following, right? So basically sine x is b. That's what we know, right? Any point on the circle. It is a comma b, where cos x comma sine x, right? So sine x is b and cos x is a. Now sine 3 pi by 2, which is 270 degrees. So this is 180 degrees. Now if we go up here, this is 180, 270 degrees. So what is the point here? Point here is a comma b. B is becoming minus 1. So here the value is minus 1. And then what is sine 2 pi? 2 pi is nothing but point here. Is same as 0. So then it's again becomes 0. From this observe, what we can observe here, right? What we can observe here, the sine value being equal for every 360 degrees of rotation. You understand? So for every 360 degrees of rotation, the sine value is becoming equal. That means if I say sine x, let's say if sine x is b, then sine 2 by x will also be b. Like if this sine 0 is 1, sorry, 0 here, sine 360 is 0. Similarly, sine 720, 360 into 2. That means 2 cycles, 2 revolution. Understood? So that is also 0, right? And into 3. You're following? So what we can say is sine 2n into pi. 2n into pi, guys. Okay? So this we can write sine, this we can write as sine of 2n pi x. That will also be, understood? Or let's look at cos. Right? So cos 0. What is cos 0? The point at a, which is basically what is cos x? Cos x is a. So cos 0 means this is the point a. So what is the value at a for x? It is 1. So cos 0 is 1. Then what is cos pi by 2? Cos pi by 2 is this point at b. So a is 0 there, right? 0. Then what is cos pi value? Cos pi value is point c. So what is a value? It's minus 1. And then what is cos 3 pi by 2? So cos 3 pi by 2 is point d. The a value is 0 there, right? And similarly, what is cos 2 pi? Cos 2 pi is again, what is that? 360 degrees or 0. That is again 1. So Same principle is applicable here. That means if cos x is a, then cos 2n pi x will also be a. That means if it is making n revolution, right? One revolution, two revolutions, three revolutions, four revolutions. If it is making a total 360-degree revolution, then the value for every 360-degree revolution will be same. So if it is 360 degrees or 720 degrees or into three times, into four times, get the same value. Okay. So that's the trigonometric ratios in radians, right? So pi by 2, pi, 3 pi by 2, and 2 pi. And also we can find for these degrees. We just need to convert that degree radian and find the value of that. Okay. Now let's look at trigonometric identities, right? So I think we learned in previous classes as well, but here also we will just take a quick review of trigonometric identity. So let's say delta OEM is a right angle triangle. So here, using Pythagoras, what we can write is the hypotenuse square equal to what, guys? Opposite side square plus adjacent side, right? So what is the hypotenuse here in this triangle? This triangle, the hypotenuse. So OP square equal M square plus OM square. This PM square plus OM square. What is OP, guys, here? It is 1 square plus what is PM square? PM is opposite side, that is P square plus what is OM? Or I can write as A square plus B square equal to 1. But we know from this, what is A? A is nothing but cos x, right? That's what we learned. And also B, hold on. And also B is sin x, right? I'll just substitute these values. So cos square x plus B is sin x, so sin square x. 1. This is the first trigonometry. Or if we need any one value, then what we can say, if we need sin square x, we can send x to the other side. That's 1 minus cos square x. Similarly, if we need cos square x, we can say the other value, that is 1 minus square x. So the first trigonometric identity is sin square cos square x plus sin square x equal to 1, or sin square x plus cos square x equal to 1. So that's the first trigonometry. Now let's look at the other ratios. So what we have is sin square x plus cos square x is 1, right? Now what I will do is I will divide this with x first. Okay. Now divide this with cos square x on both sides. So sin square x plus cos square x equal to 1. Let me divide this with cos square x on both sides. So for this, what I'll do is I'll split this cos square x to both values here by cos square x equal to 1 by cos. So cos square x, cos square x. Then sin by cos is tan. So I can write this as square x 1 equal to 1 by cos is secant. So square x. Or I can write this as secant square x minus tan square x to 1. So that's the other trigonometric identity. Then the other trigonometric identity that also we can get from this one. That is sin square x plus cos square x equal to 1. Now divide with sin square x on both. That is sin square x plus cos square x equal to 1. Divide by sin square x on both the sides. So by sin square x by sin square x. Now split that into both sin square x and cos square x. This becomes cos square x by, hope you're following, guys, equal to 1 by sine square x. Now, the sine square x and sine square x I can cut. So this becomes 1 plus cos square x by sine square x. I can write as cot square x. Right, guys? So cot x is reciprocal of tan. Tan is sine x by cos x. Cot by cos x by tan. Now, 1 by sine is cosecant. So I can write this as cosecant square x. This is the trigonometry. Or I can also write as cosecant square x minus square x as 1. This is another total 3 trigonometric identity. Sin square x plus cos square x is 1. Secant square x minus tan square x equal to 1. And then cosecant square x minus cot square x equal to 1. Okay. So these are the 3 trigonometric identities. And now we will see some uh, and before we get into the problems, let's look at the sign, right? So for various trigonometric ratios, let's look at the signs. Because in earlier sessions, we learned about the anti-clockwise angles are positive and the clockwise angles are negative, right? So if you see here in this diagram, right? In this diagram, the anti-clockwise anti-clock means opposite to the clockwise. This angle is denoted positive here, right? The anti plus x. So it is clockwise, right? This is the clockwise direction. So these angles are negative. That's why here in the fourth quadrant, you see this angle x is mentioned as minus x. Right? So what will be the value of sine and cos for uh, clockwise angle and anti-clockwise? So in the first quadrant, sine x value, right? Sine x is what? B in the first quadrant. And what is cos x? Cos x value is A, right? Now, what will happen if it is in the fourth quadrant, right? It is in the fourth quadrant. The x value is sine of minus x, right? So what is sine of minus x? Here, if you look at the point Q here, point Q is a comma minus b. So the y quadrant is sine value. So what is the value here? Minus b, right? So what is b generally? B is sine x, right? So can I write this as minus in place of b? If I write as sine x, then let's say sine of minus angle, put minus of sine. Following? The sine of minus 30 degree is nothing but equal to minus sine 30. Sine 30 is 1 by 2, so value is minus 1, right? And similarly, let's look at what happens to the cos value, cos of minus x. What is cos of minus x here? From the point Q, this value is a, right? So cos of minus x equal to a. What is a? Cos x. So here we are not getting minus cos x. So sine of minus x is minus sine x and cos of minus x is cos x. That's the sine, right? So the same applies for the thumb rule is in the first quadrant, all trigonometric functions. Okay? And in the second quadrant, which term is minus here? X term is minus. So whichever has an opposite side, those values we will get as minus, right? Like sine has opposite side. So sine will be minus. Cos has adjacent side, which is the, sorry, hold on, please. The second quadrant is uh, adjacent side is negative. X value is negative. That means sine is positive, right? And cos is negative. So whichever has adjacent, that will be uh, cos is negative. So tan is anyways the ratio of sine and cos. So that will be negative. And secant will also be negative. So sine and cosec are positive. The remaining are negative. Okay. So we will have a table here. Let's look at it. So let's draw the quadratic plane here, guys. Okay. Let's draw the quadratic, which is x here, y here. here and minus y here, right? So this angle, right, the anti-clockwise is x, right? The anti-clockwise angles are x. So if it is in anti-clockwise, this is the first quadrant, second, this is the third, and this is fourth. What happens to sine? So sine x is positive here because sine x is what? Sine x is P, which is the y quadrant, and cos x is A, which is the x quadrant in any point. Let's say I'm in the previous example, unit circle, which has points 1, comma 0, 1, then minus 1, 0, and 0, minus 1, right? Here, if I take any point P, which is A, comma B, right? It is making angle A, right? This is an A, this is an A. Then, if you look at the first quadrant, the sine value is what? Y coordinate, right? B. So that is positive here, right? And here also, quadrant also, y value is positive. That's why here, both in the first quadrant and second quadrant, the sine x values are positive. And if we go to the third quadrant, the y-axis is becoming the minus y. Third and fourth quadrant, the sine values will be negative. You're following? Right? Like that. So you just remember sine means y coordinate. So y coordinate is positive in both first and second quadrant. In third and fourth quadrant, the y value is negative. So that's why you'll get negative values for sine x, right? Similarly, cos x. Cos x is x quadrant. X coordinate. So in the first and fourth, it is positive. So if you see first and fourth, it is positive, and second and third, it is negative, right? That's why we have minus here. Now tan is the ratio of these two, sine by cos. So in the first quadrant, it will be positive, and the third quadrant, where both the values are negative, as it is a ratio, minus minus gets cancelled. So first and third, it should be positive, remaining two are negative, right? And same cosecant. Cosecant is also reciprocal of sine. So whatever the values that applies to sine, the signs, the same for cosecant. Plus plus. And then secant is same as cos. And cot is same as tan. So you follow, right? So basically the sign convention depends on the sine and cos values. So sine is y coordinate. Sin x is y coordinate. Y coordinate. Y coordinate is positive in one. Yeah, and similarly, x coordinate is 6, that is positive for the fourth one. All right, guys, so hope you understand how this will. For example, if I get a value for tan as a minus value, for tan something is minus value, then possible values for that must be either in the second quadrant or in the third quadrant. Tan can are tan can are because it's a issue of sine by cos. So in second quadrant, sine is positive, but cos is negative. In the fourth quadrant, cos is positive, but sine is negative. So that's why the tan value will get as negative. Okay. So this is the sign conventions for trigonometric ratios in a quadratic plane. All right. Now let's look at some practice. Let's do some practice. So if cos x is minus 3 by 5, so cos x value is minus 3 by 5. So where do we get minus values for cos? Guys, it can be in second quadrant or third quadrant. So here he also gave x lies in the third quadrant. There's a hint here. So, okay, x is in the third quadrant. Find the values of the other 5 trigonometric ratios. Okay, so x is in the third quadrant. So let's just for your reference, just a small x minus x, y minus 1. This is first quadrant, second, third, fourth. So x is in third quadrant. So somewhere here. x is somewhere in the third quadrant. Find the other values. So cos x, if I know cos x, just use the trigonometric identities. We don't need to follow the traditional method of using the Pythagoras, all that stuff. As we know trigonometric identities, let's just use that. So we know what is the trigonometric identity. Sine square x plus cos square x is 1. So we know cos x value. So sine square x I'll keep as is. And in place of cos x, let's substitute this value. Minus 3 by 5 whole square 1. So I can write this as sine square x plus this 9 by 5 equal to 1. Then what is sine square x? Sine square x value becomes 1 minus 9 by 25. So what is 1 minus 9 by 25? The LCM is 25. 5 is by 25. Then what is sin x? Sin x is plus or minus square root of by 25. Why? Because I'm taking plus or minus here because yeah, let's not use plus or minus right now. So sin x is square root of 16 by 25. What is sin x? Sin x can be plus or minus value, right? Can be minus what is this value 4 by 5? Can be 4 by 5 or minus 4 by 5. Why I am taking this is sine has both positive values and negative values. Then in third quadrant, what should be the sine value? Sine value is negative. So if it is the third quadrant, then I should say sine x equal to minus 4 by 5 because the y quadrant is minus here. So sine x is minus 4 by 5. Now, if I know what is sin x and what is cos x, I can quickly find the other ratios, right? And what is tan x? You tell guys, what is the tan x positive value or negative value here? It is in the third quadrant. In the third quadrant, we have both minus values. So what we will get, the answer tan should be a positive value. So tan is what? Sin x by cos x. So what is sin x, guys? Minus 4 by 5 by minus 3 by 5. So 5 gets cut. So minus minus also gets cut. So it is 4 by 3. That is tan x. Then what is cot x? Cot x is reciprocal of tan. So that is 1 by tan x. That is 3 by 4. Right? And then the remaining. So cosec. So the cosecant x is 1 by sin x. So what is sin x values, guys? Minus 4 by 5. So 1 by minus 4 by 5, I can write that. And similarly, secant x is 1 by cos x. So that is 1 by minus 3 by 5 that I can write as minus 5 by 3. So this is how we can find all the remaining trigonometric ratios if we know any one trigonometric ratio. So here what you need to do is you need to use the trigonometric identities and also which quadrant that x value, the angle is in which quadrant, that is also important. Based on that, we need to determine whether we should take a positive value or a negative value. Okay. So here sin x, I must take minus 4 by 5 because in the third quadrant, sin x value is minus because the y quadrant is minus. So if I take a positive value, all the answers will get right. So hope you understood, right? How to solve if you know one trigonometric ratio, how to find the other. Let's do another in the radians this time, right? So here, sine of 31 pi by 31 pi by 3. I write this as, it's like a fraction, right? I want to write that the multiples of 2 pi because I know 2 pi is one revolution. The sine value is same for every one revolution, that is every 2 pi. So can I write this as 10 pi plus 1 by 3 pi? Can I write this? So 10 pi plus pi by 3, which is, if I take the LCM, this is 30 plus 1, 31 pi by 3. Yeah. So I wrote this as a mixed fraction. So sine 31 pi by 3, I can write as sine of 10 pi plus pi by 3. So what is 10 pi? 5 into 2 pi, right? That means 5 revolution. You following, guys? So sine of, I can also write this as 5 into 2 pi, right? Plus pi by 3. Now, what is the sine of every revolution, right? So sine of 2n pi. So we learned it before, right? Sine of 2n pi plus x equal to sine x. Every time, after every revolution, we'll get the same value, right? If it is x degrees, x degree radian, after 2 pi, it is 2 pi plus x. After another 2 pi, it is 4 pi plus x. After another 2 pi, it is 6 pi plus x. So 2n pi plus x will get the same value, that is sine x. So I can write this as sine. After 5 revolutions, it is coming to the same position. It is sine pi by 3. What is sine pi by 3? Which is sine 60 degrees, right? Sine 60 degrees. Pi is 180, right? 180 by 3 is 60. So what is sine 60? Is root. So this is how we can simplify uh, a trigonometric ratio value if it is in radian. Okay. So thumb rule here is for every revolution, that is for every pi radians, the value is same. Pi plus x, sine of 2 pi plus x is sine x. Similarly, cos of 2 pi plus x, if it is n number of revolution, same. Similarly, we also have cos of 2n pi x will also be cos x. Understood, guys? All right. Now, let's look at this one. Tan x is given and x is in the second quadrant. Find the remaining metric. This is the quadrant. This is x, this is y, this is minus x, this is minus. First quadrant, second, third, and fourth. So x is where? Here. So this is the quadrant. Tan x. If tan x is there, which trigonometric identity we can use between tan? So it is 1 plus tan square x secant square x. So that we can use. So tan square x we need to find. Let's substitute the value. 1 plus, in place of tan, I can substitute minus 5 by 12 whole square. That is 1 plus 25 by 144. This becomes 144 plus 25 means 169 by 144. So then secant x I can write as square root of 169 by 144. That is plus or minus 13 by 12. So secant x I got. So then what will be cos x? Cos x can be plus or minus 12 by 13. It is the reciprocal of secant. So now cos x is plus or minus 12 by 13, and this is in the second quadrant. So what is the cos value? Cos is what? X coordinate. So what is the x coordinate here? Minus x. That means in the second quadrant, x is minus. That means the cos value, I must take this as cos x as minus 12 by 13 as x is in second quadrant. Following, guys? So now I know the value of cos, right? And similarly, I know tan. So can I find sine now? So what is tan x? Tan x is sine by cos. So then what is sine x? Sine x is tan x into cos x. So what is tan x, guys? Minus 5 by 12 into what is cos x, guys? Minus 12 by 13. So 12 gets cut. Minus into minus becomes plus. So it is 5 by 13. So that's sine x. So now I know sine value, I know cos, I know, and also verify sine x, I got a positive value. In the second quadrant, sine is positive because it's a y coordinate, right? Yeah. So the one that we have resolved is correct. So we know sine, cos, and tan. Now let's find cot. So cot is what? 1 by tan x. If tan is minus 5 by 12, I can write this as minus 12 by 5. And what is cosecant? Cosecant x is 1 by sin x. So as sin x is positive, we should get cosecant x is also positive. That is 5 by 13. I can write this as 13 by 5. And similarly, secant x. What is secant x? It's the reciprocal of cos. So 1 by cos x. So what is cos x, guys? Cos x is minus 12 by 13. That means it is minus 13 by. Okay. Now you understood, right? If any one trigonometric ratio is given, you can find any metrics using the identities, and also positive or negative value that you need to take depends on which quadrant is lies. All right. Now let's look at this, guys. So now we found trigonometric ratios for different values. Now let's do some more problems here. So here I have cosecant minus 1410 and sine of minus 11 pi by 3. Let's see how to find. There are two ways. One is convert these angles into degrees or degrees. But let's continue as minus 1410, right? So cosecant value, first I can solve it. First, but first let's see how many revolutions this minus 1410 is making. So if it is 360, guys, right? 360, one revolution, two revolution is 720. Notice the third revolution, guys. Right? So 720 and another 360 is 1008. But yes, 300, yeah, 1008. And another revolution is 1080 plus 360, which is mm, 1440. So this is one revolution, this is for revolutions, this is for three revolutions, and this is for four revolutions. Now, this angle is minus 1410, which will be, I write this minus 1410 as 1000 plus, right? That minus value I'm 1410 I can write as 1080 plus how much is less, guys? 1080 410, right? So 410 means 310, 330. I can write like this. Or I can write 1410, 1440 minus 30. Two ways I can write, right? Three revolutions plus the angle, remaining angle, or four revolution minus the angle. I will use this. So cosecant minus 1410, solve this as 1 by sine of minus, following. So now 1 by, what is sine? Sine of, can write this value. Let's keep minus value as is. This 1410, write as 40 minus, now 1 by 1440 is for revolution, right? Why? For revolution means sine of 1440 minus theta also be sine theta, right? So I can write this as sine of minus, minus x, sine x. Sine of minus x is sine x because it is the fourth quadrant. So sine of minus 30, I can write as 30. So 1 by sine 30 is, means it is 2. So cosecant of minus 14, 10 degrees is, the value is 2. This is how we solve if we give the angle which is beyond our fourth quadrant. Degree. And similarly, let's look at this. So sine of minus 11 pi by 3. So 11 pi by 3, can I write this as 4 pi minus pi. Yeah, let me 4 pi minus pi by 3. Can I write this? Because if I do LCM, 4 3 is 12 pi minus pi is 11 pi by 3. So proper fraction, I am writing into a mixed fraction, right? So I can write this as 4 pi minus pi by 3. So 4 pi is what? 2 revolution. So 2, I'll get the same value, right? 4 pi minus pi by 3 means sine of minus pi by 3. So sine of minus x is sine, right? So what is pi by 3? Pi is 180. 180 by 3 is sine 60. So what is sine 60, guys? Now from our previous experience, that were different metric angles, sine 30, cos 60, all that stuff. So sine minus pi by 3 is root 3 by 2. How we can simplify? Because based on the number of revolutions that we can deduce. So a proper fraction, you try to write that into a mixed fraction. You following, guys? Oh, this minus value still remains here, guys, right? Because I need to get minus 11 pi by 3. So this I will get as minus. So minus of minus will be plus, right? So that's why sine pi by 3. In any case, sine of minus x is sine x. You know that, right? So sine of minus x, which is the clockwise angle, which will be fourth quadrant angle, which is anyways sine x. So use this, solve these type of problems. So now we understood this, right? So how to solve if we get the values of various trigonometric ratios. One is you can solve using the trigonometric identities. The other is just try to find that angle into the multiple of equations. So every 360 degree is, after every 360 degree, you'll get the same value. So try to fit that into the number of revolutions in the uh, revolutions and find the remaining. So let's look at the summary. So what we learned here, we learned the trigonometric identities. So these three are the trigonometric identities. Cos square x plus sin square x is 1. 1 plus tan square x equals secant square x. And 1 plus cot square x equal to cosecant square x. And also what we learned, sin or cos, the number of revolution. 2n means pi, 1 revolution. 2n means n revolutions plus x. Any angle on top of the 360 120 degree or pi, 2 pi, right? So that is the 4 pi, 6 pi, 8 pi, right? So it's the same value. So I think we also learned, we also solved few problems based on this. Cos of 2 pi 6 is cos x and sine of 6 is sine x. All right. So this is some practice. So problems that you can work slide, right? So if you have questions on this, you can uh, slides where we have solved this type. Okay. So, one. All right. So that's all, guys. So thanks for your time, and I hope you understood the topic. In case you have any questions on it, you can reach me using Urban Profile, using my Urban Profile. So thank you. Thanks for your time.